Good evening, everyone. Just want to confirm before starting the session that whether am I audible properly. Just want to ask, you can comment it in the comment box that whether am I audible. Okay, great. So, good evening to one and all. This is just the revision of the chapter motion which you have already studied, and now we'll be dealing with some of the MCQs. Here we go. The very first one. A particle is moving in a circular path of radius r. The displacement after half a circle would be. So students, as you can see it in the figure, a particle is moving in a circle and you need to calculate the displacement after half a circle. So if we are talking about circle, you just need to think what is the starting point and what is the ending point. And I hope you all know what is displacement. The displacement is the shortest distance between the initial and the final point. So waiting for your answer, and then within a minute I'll discuss the solution. These are all the important questions which you could get and which help you to increase your knowledge and clear your concepts too. Hurry up, your answers are awaited. See students, how can we do this question? It's talking about half a circle. Means in this particular manner. The starting point will be A and the ending point will be B. Now displacement has been asked, and displacement is the shortest distance between A and B. So what could be the shortest distance between A and B? See students, it could be imaginary as well. So you might think that the shortest distance is this, and this is perfect. The shortest distance would be this. Now it's mentioned in this question that the radius is r. So what will be the displacement in this case? R and r. So the displacement would be equal to diameter, that is 2r. As simple. Okay. So this is one of the important questions which you might face, and in some of the questions radius and diameter might be given to you in the question itself. Okay, the next. The speed time graph of a car is given here. As you can see, you are given a speed time graph. Using the data in the graph, calculate the total distance covered by the car. So you can see the graph, and just for a hint, I would like to tell you all that the total distance in the graph is calculated by the area under graph. So if the total distance has been asked, you just need to calculate the area. Hurry up. Just a minute for your solution and then I'll help you out. In the speed time graphs, the slope gives you acceleration, and when it has been asked you to calculate the distance and the displacement, you need to find out the area under the figure. So, be careful. So, hurry up, hurry up. I'll explain you how, students. See, in this question, you need to see the trapezium. As you have seen it in the graph, this is a trapezium. And what is the formula of the trapezium? The trapezium area can be calculated by half sum of parallel sides, let us assume A and B, into height. In this question or in the graph, one parallel side is this and the another is this one. Further, your height would be this one. So what are the values of the parallel sides? Yes, you could see they are 5 and 30 and the height is to what? 50. Height means the value of the time. So after solving, you will get half into 35 and 2 and 50 can be cut into 25. So no need to write the half in this case. And so 35 into 25 would give you what? It would give you 875. So be very particular. The answer is 875 meter. So student, remember, these type of questions can be asked and you need to know how to calculate distance and displacement by the area under the graph. Moving ahead to the next question. Now, think it carefully. Suppose a boy is enjoying a ride on a merry-go-round, which is moving with a constant speed of 10 meter per second. So, a boy is enjoying a ride and the ride is moving at a speed of 10 meter per second. What does it imply? It implies, firstly, the boy is at rest. Secondly, it is moving with no acceleration. Third, that it is moving in accelerated motion. And fourth, moving with uniform velocity. Constant speed means speed is not changing, but an object is moving continuously. So hurry up. I need your answers no matter what. Just try. Okay. If it is constant speed, what does it shows? Very good, Eklavya. It is moving in accelerated motion. Regular movement हो रहा है और same speed से हो रहा है. So it is moving in accelerated motion. Moving ahead to the next question. Now, think again. Which of this following statement is correct regarding velocity and speed of a moving body? So you just need to tell which is correct. First, velocity of a moving body is always higher than speed. Second, speed of a moving body is always higher than the velocity. Third, speed of a moving body is its velocity in a given direction. Or fourth, velocity of a moving body is its speed in the given direction. Be careful. Think precisely, because in MCQs there are many answers which are close to each other and seems to be correct, but there is a single correct answer. Great, Eklavya. So, yes, we all know this is just the definition of velocity, that velocity of a moving body is its speed in a given direction. As we all know, velocity depends upon direction. Velocity is a vector quantity, whereas the speed is a scalar quantity. It does not depend upon the direction. Next, which of the following can sometimes be zero for a moving body? Now you need to think, which of the following can be zero? The very first, average velocity. The second, distance traveled. Third, average speed. And fourth, displacement. Which of the following can sometimes be zero? Okay, I'm getting the answers. Great. Perfect. See, distance traveled cannot be 0. That's obvious. How can we say that the distance traveled can be 0? Some says displacement. Yes, we know displacement can be 0. And when displacement is 0, students? When initial and final point coincides. जब आपका starting point भी वही हो और ending point भी वो हो. For example, if I'll take a circle and start my journey from point A and I'll end my journey again at point A. So when the starting and the ending point, that is initial and the final points are same, then displacement is 0. So displacement can be 0. But distance traveled can never be 0. Now if distance traveled cannot be 0, how come speed be 0? Because we all know the formula of speed is distance upon time. But students, average velocity depends upon displacement. Since displacement can be 0, average velocity can also be 0. That is, average velocity is equals to displacement upon time. So, which option out of these four satisfied our theory? The option C, that is first and fourth, average velocity and displacement. So, the correct answer is average velocity and displacement both can be 0 sometimes for a moving body. Next, when a car driver is traveling at a speed of 10 meters per second, applies brakes and brings the car to rest in 20 seconds, then the retardation will be. Now students, retardation is the type of acceleration, or it's another name of acceleration when acceleration turns out to be negative. The car driver is traveling at a speed of 10 meters per second, which means its initial velocity is 10 meters per second. And then it comes to rest. That means its final velocity turns out to be 0. And in what all time does it happen? It happened in 20 seconds. Dhruv Bhatnagar, you're doing some silly mistakes. Be very careful. I'll explain you this. But first, I want your all trial. Okay, it seems that you are satisfied with the C answer. Many are responding great. See students, I'll let you know how we have done this question. In this case, U is equal to 10 meters per second and V is equals to 0, T is equals to 20, and then when we will put up it in the formula of acceleration, it is V minus U upon T. That is 0 minus 10 upon 20 or minus 10 upon 20. After solving, you all are saying correct, that is minus 0.5 meter per second square. But you need to look up at the question carefully. The question is already asking about what? Retardation. Retardation means answer will come in positive. अगर वो acceleration पूछता तो आप negative बोलते. But question itself has asked you retardation means it's clear that the acceleration would come negative. And so in this case you will be writing the answer as plus 0.5 meter per second square. That's why I'm discussing these type of questions so that see it's new for you all. You will be practicing and you'll be becoming more clear when to use what. The next one. In which of the following cases of the motions the distance moved and the magnitude of displacement are equal? Which is the case, students, out of the four when distance and displacement are equal? When the car is moving on a straight road. Second, the car is moving in a circular path. Third, the pendulum is moving to and fro. And the earth is moving around the sun. See students, the answer needs to be given by A, B, C and D, not first, second, third and fourth. Be careful which option suits you. Yes, perfect answer students. It is only first. Why only first? Let me explain you. When we are talking about the car moving on a straight road, yes, if my A is the initial point and B is the final point, there cannot be any shortest distance. If I assume it's 100 meter, there can be no shortest distance between A and B. The shortest distance will also be 100 meter, and the shortest distances are displacement, and the distance moved by the object is also 100 meter. So in this case, distance and displacement both are equal whenever the object is moving on a straight road. But in a circular path, we all know the distance covered could be 2 pi r, but the displacement is 0, because the initial and the final point coincides, and when the initial and the final point coincides, the displacement is 0. So be very clear with the answer, as the answer says that the car is moving on a straight road, and the answer is the fourth one. Moving ahead, again a numerical. I know you all are speeding up in the numerical. A car is traveling at a speed of 90 km per hour. Brakes are applied so as to produce a uniform acceleration of minus 0.5 meter per second square. Find how far the car will go before it's brought to rest. So it's given that the car is moving with the speed of 90 km per hour. That means initial velocity is what? 90 km per hour. We need to convert always the velocity into meter per second. The very first step for solving a numerical must be that. You must convert into meter per second. So hurry up. I know you all know the trick for converting the kilometer per hour to meter per second. That is, you can easily multiply it by 5 by 18. So hurry up. You need to tell me the distance. See, I can help you out. U is 90 kilometer per hour, and if we multiply 90 by 5 upon 18, we will get 25. That means U is 25 meter per second. You all know acceleration is minus 5, and the car is brought to rest. That means your final velocity would be 0. So V would be 0. Now, you need to calculate the distance. So, you are just thinking the one way. If time is not given, then also we can calculate. There must be some way. See, students, how? U that we have solved is 25 meter per second. RV, that is our final velocity, is 0. The time is not given to you, and acceleration is given, that is minus 0.5. Now, you need to calculate the distance. We all know our third equation of motion. What it is? V square minus U square equal to 2AS. Calculate the distance. How? V square minus U square upon 2A. Put up in the desired value. Put up the desired values in the formula, and you will be getting up the distance. And after solving, hurry up, waiting for the correct answer from someone. The answer would be 625 meter. And when we'll move ahead, so our correct answer would be the third one. I hope am I clear to you all. Moving ahead to the next question. In a free fall, the velocity of a stone is increasing equally in equal intervals of time under the effect of gravitational force of the earth. Then what can you say about the motion of the stone? If an object or if a stone is falling and it's continuously increasing its speed or the velocity, then which of the following will be correct? That it is in uniform acceleration, non-uniform acceleration, retardation, and constant speed. See, remember, anytime if it is the case of free fall, always the answer would be uniform acceleration. Whenever an object falls under gravity and it increases uniformly, it is the case of uniform acceleration. The last, this question will help you to tell or study more about the graph. Four cars A, B, C and D are moving on a level straight road. Their distance time graph are shown in the figure below. Which of the following is the correct statement regarding the motion of these cars? Now, as you can see it in the graph, A, B, C and D, four cars movement has been shown. You need to tell which is correct. So first, car A is faster than car C. See students, the more the slope, the more the speed. So the highest speed will be of D and the slowest speed will be of what? B. So जितना ऊपर जितना ज़्यादा स्लोप है उतनी कार तेज स्पीड से मूव कर रही है और जितना स्लोप नीचे है उतनी कार कम स्पीड से मूव कर रही है. So the very first is car A is faster than car D. No, car D is faster than car A. Even car D is the fastest. Second, car B is the slowest. It can be, yes, car B is the slowest. So third was car D is faster than car C. Yes. And car C is the slowest. No, car B is the slowest. So I hope you got the answer. Thank you for joining the session. I'll be creating more short sessions which will increase your concepts and check your knowledge as well. Thank you.